Okay. All right. So last time we start to talk about inheritance, particularly single inheritance. I mentioned that there's just summarize what we did last time. We talk about single inheritance. We talk about how to deal with constructor, which is essentially when you have a inheritance hierarchy chain from your derived class to the derived class to the base class as a three class. We use the example empty thing and then label. No, sorry, locatable and holdable as an example. And then we talk about casting because I guess this is one of the challenging among all the object-oriented language and also confusing about when you're dealing with, when you create object, you're not really create object from a single class. If you see the example we got, we have MP3 thing, locatable, and holdable. In fact, when you create a object from this class, you're actually creating something from the mixture of all three of them. Depending on how you do it. Okay, so the way casting works is that, well, since I am an object, I'm representing a hierarchy of classes. Instead of saying that I'm an object, I represent a particular class. I'm really representing a hierarchy mixture, sometimes with even I use the word interference. You will see that all the three classes, they actually interfere together to affect the behavior of this object. That's why I use the word interference. And therefore, sometimes you want to control its behavior. So what I mean by control the behavior, meaning that at a particular time, I want to represent a particular behavior within this hierarchy. And that is really not so natural for as a program, because previously you wrote a program, you deal with integer, that's an integer. You deal with a struct, that's a struct. But now you're dealing with kind of a more flexible structure called inheritance, and you have to control how to expose a particular mixture of behavior you would like. And in C++, there are two mechanisms you can use. One particular mechanism, we have been start talking about that, we'll talk this a lot today, is casting. So casting allow us at least to move up and move down such that I can expose myself to a particular behavior. So I was created as a holdable, but I want to show some behavior that's actually only available to locatable. So I have to cast up to move to one level up in order to represent that. So that's one behavior called casting. So casting, sometimes casting up, sometimes you need to casting down, which is casting down is even more complicated because casting up, I just want to show the behavior of something I inherited. And casting down is interesting because I want to show some behavior that potentially I would be inherited from. So that means I'm actually going down that way. So that's interesting. We'll talk about casting down a lot today. But the other mechanism, I said one is casting, the other mechanism is called virtual function, which represents something we call polymorphism. It's also a very interesting and challenging topic. So this perspective of inheritance is very different from other programming language. For example, I summarize here that C++, we have three different inheritance. One is called single inheritance, one is called multiple inheritance, the other one is called virtual inheritance. That's C++. Java really only have single inheritance, but it has something else, some other mechanism to handle the multiple inheritance. They call it interface. Okay, it's not multiple inheritance, but it actually achieved the purpose. So Java, by the way, is a really well-designed language. So some of you might know the reason we have Java is that we kind of suffer from C++. I mean, to be honest, sorry to use the word, we kind of suffer the C++ design and such that we design the language called Java, and such that Java will supposed to do all the good thing, and then without some of the features. So you can see that Java doesn't even have multiple inheritance or virtual inheritance, whatever. They use other feature to compensate what you would like to accomplish. That's why I said, in my mind, if you're a C++ programmer, if you don't need to use multiple inheritance, don't use it. Just use single inheritance. Virtual inheritance, I will come back a little bit later. Virtual inheritance, you almost have to use it anyway. But Python is the other very popular language. Just to let you know, in Python, they have a single inheritance and multiple inheritance. They don't have a virtual inheritance. But in Python, the multiple inheritance is actually equivalent to virtual inheritance. So the C++ multiple inheritance, it is not available in Python. Later, you will see why. Okay. All right, so now let's go back to the casting. So I use this slide to represent what we have talked about class. Let me go back to this particular picture. Okay, remember we talked about this particular slide. This is what we did last time. So this is the relationship between the derived class and base class. And there are certain kind of feature that in the base class is called protected. So when you inherit it from the base class need to specify what kind of attribute or feature they are private, meaning that you cannot inherit. If you specify anything that's private, if you specify anything private, then it cannot be inherited. If you want the feature to be inherited, then it has to be specified under the protection. And then we have this different mode, whether you want to have the public mode, protected mode, or private mode in terms of inheriting. So sometimes you use a word. There is two different words. One is the keyword private, protected, public. You specify why it's not my computer, by the way. That's okay. Very interesting. See, my computer didn't went to like a power saving mode, so that means yeah, I can see that is broken. Our projector is broken. Okay, I'm sorry about that. Okay, so one is you specify what kind of attribute, like in this case, whenever you define, this is really bad. Sorry about that. How do am I able to do something? Let me shut it off and turn it on again. See if this will help a little bit. Okay, let's hope this will work, and otherwise university need to do some maintenance. So there are three keywords that with the class declaration. It basically represents what kind of feature I intended to be shared with others, including inheritance relationship. But inheritance relationship itself also have a mode of inheritance, which is protected, protected, public, and private. So don't confuse this. One set is for you to specify how a class like to expose itself to other classes or other objects. And the other one is specifically for inheritance. You can say mode of the inheritance, such as public, protected, private. Today, you will see that you can even adding one extra keyword in front of the mode, called whether it's a virtual or not. So over there, inheritance relationship has a public inheritance, private, and protected. And also you could have virtual public, virtual protected, and the virtual private. That's actually called virtual inheritance when you add the virtual keyword there. Okay, all right. So I'm going to use a different example. This is a lecture which is so important, so confusing. Okay, I try my best. So I would like to go through another set of example. Let us expose the detail about inheritance. I'm going to use a GPS as a class. So over here, this is another is a relationship, but this time I'm actually trying to inheriting from the GPS. So GPS is the base class, and GPS has only two attributes, latitude and longitude. And now I'm creating another class called labeled GPS. By the way, GPS and labeled GPS, they're both, the code is already in the master directory. Okay, so you can take a look at the code there. All right. So GPS, and so let's first take a look at the code. So let me first show you the code, and I will come back here. So let's first go to GPS. So here's a GPS. Okay, you will see that I adding a few things called memory layout. This is memory layout is something which is help us to understand the internal structure about the object. So think about what's the object. An object is something being placed in your memory. When you do a particular class, a new GPS, that means it's like a malloc. So think about whenever you have an object, think about there is a memory layout in your system. If I haven't say this, I want to say it again. It's the difference between C or C++ programmer versus any other language that I'm aware of. Except if you're trying to code everything in assembly language. The key difference is whether you're aware of the memory. So C and C++ pretty much is the only high-level programming language allow you to access the memory address. So because of that, then C programmer or C++ programmer, sometimes we need to aware about the memory layout. We want to know where's the memory so you can do all sorts of things that's specifically designed for a C++ programmer. Okay. All right, so you don't worry about memory layout. We'll worry about that later. You see that I kind of blocked this piece of code over here to just specifically for. Oh, by the way, you have a question about why I'm doing this. Like if not define, define. Those are the preprocessor. If people are curious about what they are, I can actually spend some time to explain, maybe during the office hour discussion. Okay, that's a very powerful tool for you to be able to control your source code layout. Okay, let's take a look at this. So if you look at this piece of code should be fairly simple. This is almost identical to your homework assignment number 1, except I move everything to public. Okay, move everything to public. That means it's easier for me to do a lot of things directly, not necessarily the best way. So I have a latitude and longitude as an attribute. I have a constructor. I have a bunch of function. I have operator overloading. The only thing I didn't include here is the dump to JSON, which I will talk about that a little bit later. Okay, that's GPS. And now I want to go to label GPS. So label GPS, by the way, I include all my instructional notes. You can actually take a look at that. So think about this. So label GPS is a single inheritance, and it is the inheritance mode is public. Okay, I inherit from GPS, and the only things I added to that is called labels. So what is a label GPS? I want to be able to create a GPS location, but this GPS location has a special semantics or some kind of name for that GPS. So that's why I create this new attribute called label. And now if you take a look at the constructor is essentially has the double, which is the corresponding to the constructor of the GPS class, the base class. And then I add another attribute, which is a string. By the way, this is not C string. This is a C++ string. You're probably familiar with C string. C string is anything declared as a character star or unsigned character star. Either of those, you can represent that as a string. But in C++, it has a different function called std string. Std string, the main difference is that you no longer need to use things like a string copy or string comparison and things like that. You can pretty much everything operator overload already. So for example, string concatenation is overloading of plus. String comparison is overloading of equal. Okay, so by the way, operator overloading happens a lot in C++. So they kind of make the standard string processing a lot cleaner. I shouldn't say cleaner, a lot easier. You don't have to remember using string comparison and things like that. And also a lot of safety feature. I mean, in the C string, you have to always make sure you put a \0 at the end to represent the termination of a string. But in C++, it's automatically handled by the C++ string library. Okay, so essentially, you have a label GPS, you have to define another operator overloading and things like that. Okay, so that's label GPS. That's represent the slides. Not this one. Where's my PowerPoint? Ah, here. This represent this relationship between label GPS and the GPS. Okay. All right, so now I want to talk about, if I have this two class, GPS DD and label GPS. Now we want to look a little bit about memory layout. I want to know where is the memory location of the GPS DD corresponding to label GPS. So by the way, I want to know one thing. If I have a class called GPS DD and another class called label GPS, and GPS DD has two arguments called longitude and latitude, and then label GPS has a variable called label, which is the standard string. My first question to you is that you think that this three variable means longitude, latitude, two double, and the string, are they actually putting together, or they kind of putting in two separate places in your memory? Sometimes I feel my question might not get to you clearly. Was my question clear to you? Okay. Do you think they're together or they are separate by some distance? Yes.
Separate, right? Because their ASCII values are different.
Okay. Their ASCII value. Why is the ASCII value different? What do you mean by ASCII value?
I mean, one's a string and one's a number, right?
One is double, right? Two of them are double, one is a string.
So the
Okay.
ASCII value-
Well, that's a good question. So it looks like the string usually is a character, right? But double is a number. Okay, so now I want to ask you, how much memory do I need to represent a double? How many bytes of memory? How do you find out? Yeah, I heard something.
8 byte.
8 byte, okay. Usually it's 8 byte, not necessarily. 30 years ago, it was not 8 byte, it was 32-bit, 4 byte. Okay, so how do you know how many bytes about a particular variable in C or C++? How do you know that the environment? So that's I would say the beauty or the challenging part about the language C. I'm not talking about C++, I'm talking about C. Is that if you write a program, it might not work in every single environment. If you assume that the variable take how many bytes in this particular environment. So, I mean, to be honest, today, if you use double in most of the environment you're dealing with today, double is 8 byte. Integer is 32-bit. And long int or long, which is a long integer, is 64 bits. And pointer, which is address. Oh, by the way, how many bytes is represent an address? Okay, now after I discourage you enough, everybody becomes silent. Okay, it depends on your 60-bit, 64-bit computer or 32-bit computer. If you're 64-bit computer, your address is 64-bit. Your if you're using a older version or whatever, the more traditional is a 32-bit architecture, then your address is 32-bit. So sometimes you see 32-bit version of Windows and 64-bit. That's the difference. So you can see that it's confusing because you're writing a code and you don't necessarily know what kind of architecture, what kind of representation in the basic type, such as integer, character, string, or whatever. Okay, so I want to address your question first. Yes, it is ASCII representation when you interpret the string, but ultimately, whatever bytes it needs to go back to the memory in some binary form, which is a 0 and 1. So I'm going to use a bunch of 0 and 1 in 64-bit to represent a double, and I'm using 64, 0 and 1 to represent address. I'm using a lot of 0 and 1 to represent ASCII as well, because ASCII code is essentially a byte encoding about each of the character. Okay, so that's, but I want to get back to you. First, how do I even know how many bytes? Let's use this piece of code to show you. Okay, I'm going to do this. This part, I call it find out how many bits, how many bytes of a particular data type. Okay, how do I actually find out the data type? So the way is I'm going to use printf. I would say size of integer on this computer is %d. And then I would say size of int. Okay, so there is, remember we talk about operator overloading. There's a one operator you cannot overload is size of. If you remember the last time I showed you the size. So size of is operator for us to realize how many bytes, because this is important. I want to actually check on this as a programmer to make sure if part of my logic is memory size related, then it's my responsibility to check how many bytes are needed to represent this particular data type on this platform. And that information is programmer's responsibility. Sorry, if you're a Python programmer, don't worry about that. Java programmer, you don't need to worry about that. This is only specific to C and C++. But by the way, that's why a lot of popular application today was not developed by C++. I mean, it's because C++ programmer does need to worry about more stuff than a Python programmer. Okay. So I'm going to change this to double. And I'm going to change this to character star, which is a C string. Okay, here I'm going to say size of double. Here I'm going to say size of character star. Okay, so this is the way you can realize what kind of environment you are dealing with. And then in the code, you determine those parameters and adjust the rest of your program according to the result from here. Okay, it's, by the way, size of is an integer, so you can assign that to, you see that when I do printf, I use %d to print it out. Okay. Okay, so it basically complaint giving me the warning is to actually use a long unsigned integer to represent size of. So size of is not the %d is a long integer. So I will do whatever they said. So that's why I look at the it's a warning. %d will work because they're compatible. So I will say LU, right? Is that right? What they asked me to do? Okay, so now let's try to run this program. Let's look at the first three lines. You see over here, this is the three line. It just generate. So you can see that size of a integer on this computer is a 4 byte. And size of a double is 8 byte. And then size of a pointer is 8 byte because this computer is 64 bits architecture. I mean, you can, the other one you can, I just want to say that usually in the environment, we have another type of integer called long integer. If I do long, I forgot the difference between long and long. I'm going to do both of them. One is long, one is long. That's kind of confusing, right? And sometimes if you run the same program between Mac and Windows, you will actually get two different answers, even for the same hardware. Just the operating system they have. So I actually print out both long and long. Okay, both long and long on my computer is 8 byte. Okay, so that's the data structure. Okay, so now I go back to, so hopefully now you know how to find out the size of the variable or the data type. You can actually use size of to verify the size of a data type, or you can actually use size of directly on variable, which they will tell you what's the size of the data type that the variable was created. So size of is very useful as a C programmer. Okay, any question? Okay, yes.
Sometimes use bytes
We always, in C or C++, we always use bytes to represent because a byte is a byte. That is universal. A byte is a bit, sorry, a bit. However, when you go low level to do the control, when you use a C programmer, C to control some low level, like a hardware stuff, then usually we'll go with bit because each bit represent one control. Yeah, just historically that way. Yeah, but I kind of use byte and bits interchangeably represent that, but 1 byte is 8 bits. Okay, any other question? Okay, so, okay, hopefully we understand this part about how do you find out using size of operator. And then I'm going back to the question, well, how do I know whether the two variable longitude and latitude, are they placing at the same location kind of consecutively together with the other variable called label, or they're actually being placed in a different location? What do you think? Okay, if you're not sure, can you actually tell me how do I find out whether they are in, how do I answer this question? By the way, I don't know the answer. So that's why I'm asking you, okay? So we don't know whether their memory location in terms of the attribute and this two attribute and the attribute of a derived class. I mean, how do I find out how close they are or how far away they are? How do I find out? How should I find out? Yeah.
Do like that, where it says before the code was his label address.
I have this code. Okay, I'm sorry, I'm already putting here. You know what? Yeah, I actually use printing the address. I'm printing the memory address and I know where they are, right? So let me show you the code. Then I want to tell you what it is. Oh, you're smart. You actually look at that already. Good. Okay, let me tell you that what I did. I had a bunch of code, but then here, you see this few lines of code? I'm trying to print the address of this different thing. I'm using stdcout, but I can probably, let me just, for those of you who are not familiar with this, I'm going to do exactly the same thing, but I'm actually going to use the printf to do this 3 line. Okay, I'm going to do printf for this 3 line. So essentially, I'm just print the address. So I'm going to say printf label address is equal to %p. I think for pointer, I use %p. And then what I did, you can see that how similar of these two semantics. And then I'm going to use this notation of address. Okay, this line is the same as this line. So what I did here is that I'm printing the address of this variable because I create an object called GPS TLC UC Davis. And that object was created, I believe, as a label GPS. And then I basically put dot label, which is the variable contained in the derived class. And then I put an M sign, that means what's the address of that variable. And then what let me do one more, and then I will just run the program again. And longitude is %p with \n. And then at the end, I do like this. Okay, so I'm going to only modify 2 lines so you can contrast. You understand the difference between printf and stdcout. They're really similar, by the way. They're really similar, except you don't need to worry about the format string. Format string is like a %p, \n, %d, those kind of things. It will automatically figure out by the compiler. The compiler is actually no. Okay, if you use this, this must be an address, and therefore they will internally just shuffle %p for you. Okay, that's the difference, right? All right, let's actually look at the result. Here. Okay, this 3 line is the same as the next 3 line. Okay, they're the same 3 line. So this is the address of the label. And then you have the address of this. Okay, so you have this 3 address. And now can you tell me whether they are together or they're separate? By the way, there is a term called hexadecimal. Do you understand? Have you seen this before? I don't know if some of the instructor didn't cover hexadecimal. It's a 16-base number. So how many of you haven't heard about hexadecimal representation? So you saw a number from 0. Okay, some of you are, okay. So sorry, just for those of you who understand this already, I want to give a really quick introduction to hexadecimal because this is so critical to understand. Okay, so usually binary is a 0 and 1. That's it. Okay, 0 and 1. So decimal is a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's decimal. It's base 10 number, means that whenever you have a 10, then it carries to the next digits. Okay, so that's decimal. Hexadecimal is 16. Which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so it's a 16-base number. Whenever you went over 15, which is 16, you actually have a carry to the next digit. Okay, that's 16. And of course, if I write down a number looks like this, it's actually very hard to read. So I'm actually going to model. So hexadecimal, essentially 10 means A. I would use the lowercase, is fine. Lowercase, uppercase is fine. B, C, D, E, F. So essentially, a hexadecimal digits is not only from 0 to 9, but it's really from 0 to F. Okay, so that represents all the hexadecimal numbers. So okay, so is that good? So just tell you that's just a different base number. So in computer science, the most popular number when we want to do internal processing is actually binary or hexadecimal. Hexadecimal is much nicer. Why is that? Because this is a power 2. It's 2 to the 4. That's okay. Whenever you do a hexadecimal, when you want to do anything with power 2, it's easy. If you have a decimal when you want to multiply 2 numbers, it's pretty complicated. But if you want to do hexadecimal with multiply by 2, it just shift 1 bit. So from the computer performance, it's much faster if you can handle only in the hexadecimal number. Okay, so that's very quick introduction to hexadecimal. It's very useful. And I don't know, sometime we just okay, so now I'm going to run the program. Now let's take a look at the result. So now all of you should know that this representation is a hexadecimal number. So you can see that, you can see some E, you can see some F, and you can see probably other letters. But in this case, it's really just F and E. Okay, F is a 15, E is 14. All right, so now we're comparing. Let's first take a look at this two, compare this two. Longitude and latitude, this two address. By the way, this is a hexadecimal representation of a memory address of the first byte of the variable. So usually when we talk about address of a variable, we usually say that's the address of the first byte. All right, so can you tell me longitude and latitude, which one has a smaller memory address? Which memory address is smaller compared to this two number? Latitude, right? Latitude start with 0 and longitude start with 8. So I only read the last two digits of the hexadecimal. So longitude is E8, E8, and latitude is E0. That means a 0 and then come to 8. And okay, the second question, what's the distance between these two addresses? 8, right? E8 minus E0 is 8 byte, right? So what is a latitude? Latitude is a double. How many bytes is a double? 8 bytes, right? So you can see that this fits exactly. The system reserved 8 bytes for longitude and latitude. And therefore, the first byte of the latitude is E0. So I use the next 7 bytes, which is I'm going to use E0, E1, E2, E3, E4, E5, E7. From E0 to E7, those 8 bytes is exactly what I needed for represent that double. That's 8 bytes. And then now E8 starting, I'm putting my longitude, which is what? Is the next 8 byte is another double. So it fits perfectly. So now as a C programmer, you got a glorified detail about your memory, about how your memory store your data. Okay, that's the byte. Okay, so now you can think about this. This is a little bit tricky. Now, what's the distance between label and longitude? It's also 8 byte. It's also 8 byte. Let me actually show you. Let's copy this. I will show you why is that. By the way, for those of you familiar with the memory address, sorry about that. I'm only going to do this once, and hopefully everybody is clear about this memory location stuff. Okay, I'm going to use this one. This is the address I have deal with. Okay, I'm going to do it differently. So with latitude, the 8 byte is E0, E1, E2, E3, E4, E5, E6, E7. That's 8 byte. And then from longitude is E8, E9, and what's E10 is EA. Okay, is EA is 10, and then EB, EC, ED, EE, and then EF. Okay, so those 8 bytes represent the longitude. And what's next to EF? What's the next number? If you have a number EF plus 1, what's that number? It's actually F0, right? Because what's hexadecimal? Hexadecimal, if you have a 15, the next number is going to go back to 0. But then you have a carry, so that's why E become F and then become F0, which is exactly the next number, which is the label, the address of the label of the string, first byte. So the thing is that so that's why this string actually cover, I think, more than 8 bytes. That's a good question. Let's try to run it to see how many bytes it is. See, in programming, we just always try to verify. Okay, I'm going to verify this. No, I want to go here. Label size of content. Because the string is a little bit different. So I will say size of GPS TLC label, which is tell me how many bytes it will use. Let's see how it works. Okay, so you can see that the size of the label is 24 byte. Okay, it's not so natural, right? You said, well, what do you mean by a string is 24 byte? Yes, it is represent the whole object because I said this is different from the C string. C string is essentially just a pointer to character star, but C++ string is an object. It has to remember a lot of things for you such that you don't have to worry about adding a \0 at the end, which is if you forgot, you got segmentation fault. So C++ string is doing something different. That's why it needs more memory. And we can, if you're interested, you can actually try to print out each of the byte in this 24 byte. Okay, so now let's go back to this part. So this is basically F0 go all the way to the last byte should be F0 plus 23. Okay, plus actually I should say this is decimal 23, not hexadecimal 23. Okay, and then that's 24 byte is over there. All right, so okay, now I want to teach you first is how do you actually find out what is the memory address of every single byte in your memory for whatever variable size. This is important, by the way, for C++ programmer, and don't assume that everything is what you think. Always verify with this particular set of mechanism, like a size off, like a printout address. But the most important thing, go back to my previous question. My original question is, do we think that the memory location of the base class variable, which is longitude and latitude, versus the attribute from the derived class, they're actually being put together. They're putting together. So first one is latitude, the second one is longitude, those belong to the base. And immediately the next byte is what? Is label. So it means that they're really together in the memory. And that's important. You can find out through the way I do it. Okay, I spent so much time just try to show you this slide. So we have a memory location map looks like this one. It looks like this one. So you have a GPS DD with this two variable, and then you have a label GPS, which is 8 byte. Sorry, after you finish the first 16 byte of the GPS DD, that's exactly next 24 bytes, not 8 byte. 24 byte will be putting there. And that's your memory layout for your object. Okay, that's a 3 variable. I will teach you later, there are other perspectives about this object. I mean, for example, how about the function, right? When you declare an object, you not only have an attribute, but you also have a function. You have a bunch of member function, and where did those things go? Okay, don't worry about that because those functions are stored in a separate table, which we call an array or function pointer, which is associated with a class, not associated with the object. So object represent the attribute because you need to store the value. But for all the objects belong to the same class, they share the same function signature. That's why it's a separate. We'll talk about function pointer, especially when we talk about virtual function. Then you will see that in your mind, not just it's an object, but really those objects, how they be placed in your memory. Okay, we'll get to that. All right, so first, I just want to make it crystal clear that you understand when we have an inheritance relationship, their data are being put together, at least with a single inheritance. Okay, any question? That's number one message I want to get through today. When people are silent, it usually represent you're totally lost, or I'm crystal clear, which I'm not sure. Anyway, yeah, thank you. Yes. Yes, in the back.
Basically, when you type passive reference, you would get the memory address and then, and then you would copy, you would try to see if. Wait, what would you do again?
Okay, sure. No problem. I mean, from your question, I see a few issue I need to address. Number one, if let me go back to the code. Let me do a little bit reiterate about what I just did. Okay, so first I want to tell you that I add this n at the beginning. Okay, first, this is confusing. Even for me, I feel it's confusing. You see that n sign? That n sign has a very specific meaning in programming language C, not C++. Whenever you put an n in front of a variable, it represents what's the address of that variable. So this part, I want to tell you that how do I interpret this part? How do I interpret this part? This part basically say I have a variable, which is GPS TLC UC Davis dot label. This is a variable. Okay, this is a variable. It represents whatever variable it is. And if you add M sign, that means what is the address of that variable? What is the memory address of that variable? Okay, let me use a different example, easier. Let's not confuse ourselves. Let me create an integer called integer XYZ is equal to 777. Okay, so that is an integer. All right, so how do I represent the address of this integer XYZ? Where do I put a XYZ in terms of memory address? Can someone help me? How do I get to the address of XYZ? I add n sign. So if I do a printf, address of XYZ is equal to %p \n. And then over here, I set n XYZ. All right, so let me do this. If I say the content of the XYZ, content of XYZ is %d XYZ. Okay, so let's just focus on the three line, make sure that for those of you who are, okay, by the way, this is one of the hardest topic in C, pointer, address, integer. They're essentially confusing people. So this three lines of code. I declare a variable called XYZ, and then if I want to print the content of that variable is XYZ. But if I want to print the address of that variable, that's MXYZ. All right. Does that make sense? Okay. All right. So now let's look at even further. But I can actually do this. The content of the address of XYZ. Then I will do this star and you see that I can add n and then star kind of dereference. Sometimes the star means dereference. So if I have, by the way, I'm teaching C, not C++. So I add n, this is address, and I use the address, I can dereference the address, means the content of the address, star MXYZ. Then this one should actually give me back 777. Okay, and I mean, you can do the other way to do the same thing is like this. I can actually declare a pointer. I call the star XYZ pointer. I can actually do this. I declare this as a pointer. So the XYZ pointer, the data type is integer star. Integer star is a pointer type. And then I can do XYZ PTR is equal to n XYZ. I put the address of XYZ into the pointer XYZ PTR. And then I can print the content being pointed by XYZ PTR is equal to XYZ. And over here, I would say star XYZ PTR. Okay, this like a 6 or 7 lines of code basically show us how to use the word, the character and star. Okay, that's purely in C. And that's still true in C++. Okay, the same way. Okay, let's try to run it and I'll ask you a question. Okay, look at this 4 line, what we just print out. The content XYZ 777. The address of XYZ is whatever E4 is the address. And then the content of the address by XYZ go back to 777. The content being pointed by the XYZ pointer is also 777. Okay, so they're essentially everything here is represent the content and the address of the content. Okay, everybody clear with this? I just want to make sure that this is something which is important for us to understand the rest of the quarter essentially. Okay, anybody is if you're still don't understand this part, it's okay. This is I said this is the hardest topic in C. So if you are unfamiliar with this, let me know. I will use my office hour or whatever. I can record something extra to cover this. Okay. All right. So go back to your question in the back. What's your name? Yeah. What's your name? What? Caitlin. So Emily or Kavali. Okay, thank you. Appreciate that. So Kavali, the first thing is the N is the address. You understand that part? Okay, so now I'm not going to talk about because your question, you use the word reference and N. I do want to clarify that when that M sign is after a variable, after a data type, it becomes a reference, not the address. So I'm using, wait a minute, well, okay. I'm using M to represent address, or I'm using M to do this as an address. So whenever you see an M in front, this is just like the example XYZ, it's the address. However, you also see I have used the variable, let me actually put it this way. I use a variable, say GPS, DD, and then after that, I have an M. If I use GPS and this is essentially a reference data type. This is if the M sign is right behind a data type, it's not an address, it's a reference type. But an equivalent way semantically to say this is actually equivalent to not syntactic, but semantically equivalent to this declaration, GPS, DD, star. This is semantically, not syntactically, because there are still difference in terms of when you use it in the language. So for a C programmer, whenever you do a data type with star, what does that mean? That's a declaration of what? It's a pointer, right? When you declare something as a data type integer star, long star, double star, or GPS DD star, they're basically represent this is a data type. It's a pointer to this particular data type as a data type. And similarly, if you put a GPS DDN, this is like int n. You can do int n, you can do double n, you can do GPS DDN. This represents a reference type. Semantically, it actually represents it is a reference or it's a pointer without giving you the address of this. Okay, if you want to obtain the address in C or C++, you still have to use the N in front. Okay. Yeah.
C++ for declaring a pointer, do you ever use the star? Like you just use the star?
I always use star. In fact, I forgot whether I said this or not. Adding an and after a data type is a new way C++ introduced probably around 2000, maybe a little bit after that, is try to have a way such that you're unaware of the concept pointer, and then I can represent reference.
You can still use the star to
You can use a star. In fact, I always use star because star is, to me, as a C programmer, it's so clear that star, I know precisely what it is. And sometimes causing problem. I'll show you immediately. Okay, so the difference between, okay, that's a good question. I wonder about what's the difference between these two? If I declare a variable, which is a GPS, DD, and say GG, okay? And I declare another one, which is GPS, DD star, GGG, okay? Assuming I have this two variable. If I want to access to longitude, latitude, over here, I have to say GG dot latitude. But over here, if I do this, I have to say GGG pointing to the latitude. You see that? So that's why I'm saying that they're both represent the concept as a reference, but syntactically, I have to use it differently. And this is a C++ way of using a pointer. When I want this, I want access to one particular attribute. Pointing by this, I just do like this. But GG is still a reference. In fact, to me, it's a pointer. But when you want to use this pointer, you have to use the dot notation. Okay, so if you do this, if I do this, I only have a 1G. Okay, so now I remove the pointer. If I want to access latitude, it's like this. So that's why I said this three compare. You can see that the new construct, so referencing G plus or C++ is semantically is the same as the pointer because it's a reference. But syntactically is actually looking at like an original variable. So that's why it's confusing. That's why for me, I prefer to use number one and number three because it syntactically, if I feel that's okay to accept using the pointer. Well, technically, if you want to use a reference only, you can actually write a C++ program without using dash greater than, because you always use that. As long as you don't need to access the address as a value, then that's okay. Okay, it's complicated, but I feel you guys, as a C++ programmer, you really should know about a little bit about historical reason for all this feature. Okay. Any question? All right. So I'm going back to, I have 3 minutes. I want to get through this part and then I can let you go and continue on next week. So, so the reason I talk all about this is about cast up and cast down. Okay, I have two classes called label GPS and GPS, and we actually argue using program to show that in memory, they're actually in the same place. All right. So now we're talking about cast up and cast down. So what does cast down really means? Cast down really means I was here. Now I can, sorry, I was here. I actually moved to the GPS, cast up to move the GPS, and cast down is from GPS. I moved down to label GPS. Okay, so I will use this program. Let me see. I'm going to use this example. So over here, I have let me use GPS TLC first. So first GPS TLC, what is a GPS TLC? I must define somewhere. Where is that? GPS TLC. The program is getting big. Okay, GPS TLC here. Okay, GPS TLC is a label GPS, right? Okay, so I'm going to tell you CAS up. Essentially, CAS up is easy. If I have a GPS, I can just say GPS DD, and then I said GPS TLC UC Davis. Okay, this is how I CAS up, because GPS TLC UC Davis is a derived class, and I want to move up to the one of my base class. This is called CAS up, and such that I can fully enjoy some of the feature might not be available to me if I didn't do this CAS up. I show you the example foo, that I have 3 different versions of the foo function, one associated with the base class, but it has been overwritten by the label GPS. Therefore, I'm actually going to CAS up to be able to enjoy that function. Okay, so now I'm going to show you the CAS down. It's a bit tricky. So take a look at this. If I have a function called if I have a function called GPS copy. See that this line, I'm talking about this line. This line essentially copy the value of GPS TLC UC Davis, but I copy of the CAS up. So essentially this line, I basically take the portion of GPS DD out of that GPS TLC UC Davis and store in another object called GPS copy, which is really just GPS DD. Okay, so I make a copy of that. So essentially, it's CAS up and then make a copy. And now I'm going to do this. Can I then CAS down to this line? So this is the line I'm talking about. I have another copy. So this one is CAS up copy, and now I have a CAS up. Now I label GPS, I try to CAS down, and then I perform a copy. Would that work? The answer is no. I'm going to get a compiler error. Okay, you see that I'm trying to, if you look at all the error message, it basically say, I cannot do this. It's doing a redefinition or, oh, wait a minute, that's different. I forgot to get rid of this actually. Okay, I still have the arrow, but it basically say no matching conversion of the C style. When I try to CAS down and make a copy, I cannot do that. I cannot do that. But you remember last time I showed you I can do that, right? Why this time I cannot do that? Because I did an upgrade? No, because last time I was using pointer. And this time I can use an address. So the same code over here, if I add the M sign here, the only difference is adding that N and without M, adding the reference. And then I do a make, it works. Okay, so now I want to, our time is up, so I just want to ask you to think about this. We'll start on Tuesday. And please remember to start to install your JSON stuff because it is very useful. Next Tuesday, we're going to do participation, just to let you know. So the difference between these two, what's the difference between these two lines? It's cast down, but one is cast down with a regular class, or the other one is cast down with a reference. Okay, so compare those two. Why the first one will give you a compiler error, the second one is okay. All right, so I will see you on Tuesday.